Okay, so pendulum motion. Now, on the face of it, it seems completely different from springs moving in straight lines. But when you start to look at Newton's second law and how things work out, it can end up with the same differential equation. Now, in the notes, one assumption that's made right away is that we are doing a simple pendulum. And what that means is that all of the mass is concentrated at a single point at the very end of a massless, perfect, ideal string. In Flip It Physics, they go through a little more detail on what you would do with a physical pendulum. That is when the mass is spread out over some object that's more realistic. And in your labs, Lab 0 and Lab 1, you will be looking at measuring things like frequency and all of that with simple pendula for Lab 0 and a physical pendulum in Lab 1. Now, I talked about our assumptions about the mass. There's a second assumption that is generally made, and that's called the small angle approximation. If you just work out Newton's second law and turn the math into a differential equation, you do not get the same one that we had for simple harmonic motion. Instead, you get something super ugly because it has like a sine function in it. We don't want to deal with that. Physicists are lazy. We don't want to deal with that. So what we do is we use the small angle approximation. What that says is, if your angle is small enough, and this is in radians, then the sine of an angle is roughly exactly the same as the angle itself, again, in radians. Now, exactly how small enough the angle has to be, that's really a judgment call. There's a file in this module, just after this video, that will give you an idea of how close together the sine of an angle and the angle itself are for different values. In general, I would say that if you are not told otherwise, you can assume the angle is small enough. One of the things you look at in Lab 0 is actually what happens as the initial angle gets larger, and it does get significantly larger. Okay? All right, so I'm going to leave you to work through all of that and play with your equipment in your labs.